It's already recording.
Oh, it's recording? Okay, we have in this question a sample mixture of sodium sulfate and magnesium sulfate dissolved in water, to which we've added barium chloride, causing a precipitation reaction where barium sulfate forms. The question is, what is the percentage of magnesium sulfate in the original mixture, given that the sum of the mass of sodium sulfate and magnesium sulfate is 0.656 grams. That's all we know. We know that this mixture weighs 0.656 grams, and we're given that 1.256 grams of barium sulfate form. The key to unlocking this question is to assign a variable. So the variable we assign is x, and we let it equal to the mass of sodium sulfate. If the mass of sodium sulfate is x, that means that the rest of the substance in the mixture is magnesium sulfate, so it'll be 0.656 minus x. Also key to solving this problem is to understand that all the sulfate that we see in the reaction ends up in the form of barium sulfate. So if we can find out how many moles of barium sulfate we have, we can also find out how many moles of sulfate are present. And that's what we've done here. We found that there's 1.256 grams of barium sulfate, so we divide by the molar mass of barium sulfate, and that tells us that we have 5.38 times 10 to the minus 3 moles of barium sulfate, and I threw it in brackets, and sulfate. And this is the key to understanding how we solve this problem. The sulfate is coming from the sodium sulfate and the magnesium sulfate. So what we've done here is we've represented the moles of sulfate in the form of sodium sulfate and the moles of sulfate in the form of magnesium sulfate. And we see the molar mass of magnesium sulfate here in the denominator, and this is the molar mass of sodium sulfate being calculated in the denominator. So grams divided grams per mole gives you moles. So if you know the moles of sodium sulfate, you also know the moles of sulfate coming from sodium sulfate. If you know the number of moles of magnesium sulfate, you also know the moles of sulfate coming from magnesium sulfate. Moles of sulfate here plus moles of sulfate there has to equal moles of sulfate here. That is the premise of this problem. So we've set up an algebraic equation where we represent the moles of sulfate in all its various forms, whether it's a sodium salt or magnesium salt. And then we solve the equation by finding a common denominator. From here to here, I've skipped a step. What I should have had is this common denominator multiplied to give a large number, and then we would have multiplied this x by 120, and we would have multiplied the contents of this bracket by 142. But what I did is I took the product of these two numbers and I transposed it over here, multiplying it by 5.38 to give 92. And then I wrote the rest of the equation out. I distributed the 142 into the bracket. I grouped my x's on one side and the numbers on the other, and then I solved for x. Once I solve for x, that tells me the mass of sodium sulfate. Now the problem is asking us for the percentage of magnesium sulfate. So the first step is to find out how many grams of magnesium sulfate. We know the grams of sodium sulfate, so if we subtract it from 6.656, we're going to find the grams of magnesium sulfate, and that's what I did over here. The mass of magnesium sulfate is equal to 0.656 minus the mass of sodium sulfate to give you 0.602. The 0.602 I divided into the total mass of the sample, multiplied by 100 to turn it into a percentage, and we find out that it's 91.773% magnesium sulfate. We're only allowed 3 significant figures. There are 4 over here, but this is the limiting significant figure, so we limit our answer to 3 significant figures. The solution is 91.8% magnesium sulfate.